Atomic structure. Atoms and molecules. We see many things around us. They look very different from each other. In class 6, you have studied about matter and different states in which it exists. A steel glass containing water, if kept for some time, shows some bubbles sticking to the sides of glass. In this case, we can see all three states of matter at the same time. Steel glass represents solid state of matter. It will occupy definite volume, shape, and has a fixed mass. When we say definite volume, we have a rough idea that a particular solid will require how much space. A glass may be of different materials, but the space occupied by it remains constant. But it is not so with water, representing another state of matter, that is, liquid. It will always take the shape of container in which it is kept. The third state in which matter can exist is gas. Dissolved air is seen as bubbles on the sides of glass, and rest of the air fills all space around us. That is, it does not have any fixed volume. Another example is that of water, which exists in all the three states under different conditions. In solid state, it exists as ice. In liquid state, it exists as water. And in gaseous state, it exists as vapor. States of matter are interconvertible. What is matter? What is matter made up of? Why does it exist in different states? Anything having mass and capable of occupying space is matter. Thus, a stone, water, and air filled in balloons represent matter. Matter is made up of molecules or atoms. These molecules give matter its properties, and their arrangement causes matter to exist in different states. Atoms are the smallest particles of matter. A group of two or more atoms forms a molecule. But matter, which we refer to as substance, can be made up of either atoms or molecules. When a molecule is made up of atoms of only one kind, it is called molecule of a pure substance. To be more specific, this pure substance is called element. Atom, the smallest particle of an element. History of discovery of the atom. The theory of the atom dates at least as far back as 440 BC to Democritus, a Greek scientist and philosopher. Democritus' explanation of the atom begins with a stone. A stone cut in half gives two halves of the same stone. If the stone were to be continuously cut, at some point, there would exist a piece of the stone small enough that it could be no longer cut. The term atom comes from the Greek word for indivisible, which Democritus concluded must be the point at which a being, any form of matter, cannot be divided anymore. John Dalton, a British chemist, built upon Democritus' ideas in 1803 CE when he put forth his own atomic theory. Dalton's theory included the ideas that all atoms of a certain element are identical. Atoms of one element will have different weights and properties than atoms of another element. Atoms cannot be created or destroyed. Matter is formed by atoms combining in simple whole numbers. John Dalton. John Dalton, 1766 to 1844 was an English chemist, meteorologist, and physicist. He is best known for his pioneering work in the development of modern atomic theory. Dalton proceeded to print his first published table of relative atomic weights. 6 elements appear in this table, namely hydrogen, oxygen, nitrogen, carbon, sulfur, and phosphorus, with the atom of hydrogen conventionally assumed to weigh 1 unit. Structure of the atom. Atoms are the basic building blocks of ordinary matter. Atoms can join together to form molecules, which in turn form most of the objects around us. Atoms are composed of particles called protons, electrons, and neutrons. Protons carry a positive electrical charge. Electrons carry a negative electrical charge, and neutrons carry no electrical charge at all. The protons and neutrons cluster together in the central part of the atom, called the nucleus, and the electrons orbit the nucleus. A particular atom will have the same number of protons and electrons, and most atoms have at least as many neutrons as protons. The hydrogen atom is unique in that it only has a single proton and no neutron in its nucleus. The electron is a negatively charged particle that spins around the outside of the nucleus. Electrons spin so fast around the nucleus, scientists can never be 100% sure where they are located. But scientists can make estimates of where electrons should be. If there are the same number of electrons and protons in an atom, then the atom is said to have a neutral charge. Electrons are attracted to the nucleus by the positive charge of the protons. Electrons are much smaller than neutrons and protons, about 1800 times smaller. The neutron doesn't have any charge. Atoms and molecules. When two atoms or more atoms join together, they make a molecule. All matter around us is made up of molecules, including us. Atoms are usually not found to exist independently. Elements. Atoms of elements, with the exception of inert gases and a few other elements, always join together to form molecules. They do not exist independently. Hydrogen gas has two atoms joined together to form a molecule of hydrogen. Similarly, oxygen gas has two atoms in its molecule. Compounds. When atoms of different types of elements join together, they make molecules called compounds. Water consists of compound molecules made up of 2 hydrogen atoms and 1 oxygen atom. This is why it's called H2O. Water will always have 2 times the number of hydrogen atoms as oxygen atoms. Molecular formula. There are only just over 100 types of atoms, but there are millions and millions of different types of substances. This is because they are all made up of different types of molecules. Molecules are not only made up of different types of atoms, but also different ratios. Like in the figure above, a water molecule has 2 hydrogen atoms and 1 oxygen atom. This is written as H2O. Other examples are carbon dioxide, CO2, ammonia, NH3, and simple sugar or glucose, C6H12O6. Some formulas can get quite long and complex. Let's look at the molecule of sugar. C6, 6 carbon atoms. H12, 12 hydrogen atoms. O6, 6 oxygen atoms. Ions. An ion is a charged molecule or atom carrying non-zero electrical charge. Total number of electrons in an ion is not equal to total number of protons in that. An atom or molecule becomes charged either by gaining an electron or by losing it. Positively charged ions are called cations, while negatively charged ions named as anions. By losing electrons, an atom forms positive ion called cation. For example, after losing an electron, a sodium atom becomes a positively charged sodium ion, Na+. In similar fashion, when an atom gains electron, it forms negative ion called anion. For example, after gaining an electron, a chlorine atom becomes a negatively charged chloride ion, Cl-. In general, cation formed by metals after losing electrons, while anion formed by non-metals after gaining electrons. Positive ions, negative ions. Name, symbol. Hydrogen ion, H+. Sodium ion, Na+. Aluminium ion, Al3+. Potassium ion, K+. Magnesium ion, Mg2+. Calcium ion, Ca2+. Copper 2 ion, Cu2+. Iron 2 ion, Fe2+. Chloride ion, Cl-. Bromide ion, Br-. Iodide ion, I-. Oxide ion, O2-. Hydride ion, H-. Nitride ion, N3-. Sulfide ion, S2-. Phosphide ion, P3-. Radicals. Radical is defined as a group of atoms of different elements combined together to act as a single unit and carrying a charge. Any single molecule of the radical is not capable of independent existence. Molecules of a radical do not carry any charge separately, but are highly reactive in nature. There exists some exceptions to this theory too. For example, nitrogen, elemental, is a radical, not anion. Radicals, symbol. Nitrate, NO3-. Carbonate, CO3-. Bicarbonate, HCO3-. Sulfate, SO4-2-. Sulfite, SO3-2-. Phosphate, PO4-2-. Bisulfate, HSO4-. Difference between atom, molecule and radical. Atom, molecule, radical. Atom is electrically neutral. Molecule is electrically neutral. Radical carries charge. Atom cannot exist independently. molecule have their independent existence. Radical do not have their independent existence. Some elements exist as single atoms. Most of elements exist as molecules. None of the elements exist as a radical. It is the smallest possible unit of element carrying all of its characteristic properties. Molecule is a group of similar or different atoms which further can be subdivided into atoms. Radical is a group of different atoms acting as a single unit and carrying charge. It can be subdivided into atoms further. Atomicity. Atomicity is defined as total number of atoms present in unit molecules of an element, substance, or compound. In case of metals, atomicity is generally observed to be 1. In case of nonmetals, it generally varies from 1 to 3. In general observations, most elements exist either with atomicity 1, monoatomic, or 2, diatomic. Hydrogen, H2, oxygen, O2, nitrogen, N2, shows diatomicity. In case of ozone, O3, oxygen shows triatomic behavior. Atom, atomicity. 1. Monoatomic. 2. Diatomic. 3. Triatomic. 4 or 4 plus. Polyatomic. Hydrogen is said to be diatomic, having 2 atoms in its molecule. Likewise, molecule of 3 atoms is triatomic, as in case of aluminium. 4 is tetraatomic, and so on. Do you know? Oxygen gas normally is the molecule O2, but it can also be O3, which we call ozone, that is found naturally in the upper atmosphere. 66% of the mass of the human body is made up of oxygen atoms. Molecules can have different shapes. Some are long spirals, while others may be pyramid-shaped. Organic compounds are compounds that contain carbon. A perfect diamond is a single molecule made of carbon atoms. DNA found in each cell of our body is a super long molecule that has information uniquely describing every human being. Molecule of hydrogen is called diatomic. Di is equal to 2. Atomic is equal to atom. And its atomicity is also 2. H, 1 atom of hydrogen, plus H, 1 atom of hydrogen, gives HH. 2 atoms of hydrogen combined gives H2, 1 molecule of hydrogen which is made up of 2 atoms of hydrogen. Atoms of helium and atoms of neon exist independently and behave as a molecule. Molecule of helium is monoatomic. Mono is equal to 1. Atomic is equal to atom. Here, the atomicity is 1. Water is a compound, and 1 molecule of water consists of 3 atoms, which are of 2 different elements, namely hydrogen and oxygen. These atoms are chemically combined together in a definite ratio: 2 atoms of hydrogen and 1 atom of oxygen. H plus H, 2 atoms of hydrogen, plus O, 1 atom of oxygen, gives H2O, one molecule of water. When atoms of different elements, either as molecules or simply as atoms, coexist in a definite ratio but do not combine, we get a mixture. Air is a mixture of gases. It contains oxygen, 21%, carbon dioxide, 0.03%, nitrogen, 78%, inert gases, 0.97%, molecules of inert gases, He, Ze, Kr, Ne, Ar, plus molecule of oxygen made up of two atoms, O2, plus N2, molecule of nitrogen made up of two atoms, plus CO2, one molecule of carbon dioxide made up of one atom of carbon and two atoms of oxygen, gives air. You see that air is a collection of different atoms and molecules, but by itself, it has no molecular composition like water. Valency. The chemical formula of a compound tells us the number of atoms of the different elements present in a molecule. To know the formula, we must know the elements present in the compound and the valencies of the elements. Valency can be defined as the combining capacity of an element with other elements. Since every atom prefers to be stable, it is necessary that its outermost shell, except the first, should have 8 electrons. This stability is achieved by accepting, donating, or sharing electrons present in the outermost shell. The outermost shell is called the valence shell, and the number of electrons that an atom needs to accept, donate, or share is called the valency of that element. The valency of an atom is always a whole number. Depending upon its valency, an element is called monovalent, valency 1, divalent, valency 2, trivalent, valency 3, and so on. Let us understand it with the help of some examples. Example 1. 2 atoms of hydrogen combine with 1 atom of oxygen to form 1 molecule of water, H2O. Therefore, the valency of oxygen is 2. Example 2. 3 atoms of hydrogen combine with 1 atom of nitrogen to form 1 molecule of ammonia, NH3. Therefore, the valency of nitrogen is 3. Example 3. 1 atom of sodium combines with 1 atom of chlorine to form 1 molecule of sodium chloride, NaCl. Therefore, the valency of chlorine is 1. Thus, valency of sodium is +1 and that of chlorine is -1. Plus sign indicates that atom will lose electrons and numeral after plus sign indicates number of electrons to be lost. Similarly, minus sign indicates gain of electrons and numeral after minus sign indicates number of electrons to be gained by the atom to acquire stability. Thus, sodium atom has a tendency to lose 1 electron and chlorine atom has a tendency to gain 1 electron. When an element gains electrons, we put minus sign, and when an element loses electrons, we put plus sign. Variable valency. For some reasons, some elements show variable valency also. It means they have more than one valency. For example, iron shows variable valency of +2 and +3. This is indicated as Fe2+, Fe3+, or iron 2, iron 3, or ferrous, ferric. The lower valency is shown by adding us to the name of element, and higher valency is shown by adding ic to the name of element. Hence, iron whose name is ferrum becomes ferrous for +2 valency and ferric for +3 valency. First 20 elements in the periodic table. Atomic number, elements, symbol, valency. 1. Hydrogen, H, 1. 2. Helium, He, 0. 3. Lithium, Li, 1. 4. Beryllium, Be, 2. 5. Boron, B, 3. 6. Carbon, C, 4. 7. Nitrogen, N, 3. 8. Oxygen, O, 2. 9. Fluorine, F, 1. 10. Neon, Ne, 0. 11. Sodium, Na, 1. 12. Magnesium, Mg, 2. 13. Aluminium, Al, 3. 14. Silicon, Si, 4. 15. Phosphorus, P, 3. 16. Sulfur, S, 2. 17. Chlorine, Cl, 1. 18. Argon, Ar, 0. 19. Potassium, K, 1. 20. Calcium, Ca, 2.